All right, got cut off right before the end, so let's finish this up. We know that the gravitational potential energy changes, okay? And since we know that we're doing work to overcome friction, we also know Q changes. Where we were about to get to is, since the gravitational potential energy changes, we need to know by how much it changes. Therefore, we need to know this height difference. I've labeled this X. We know this is 5 meters. We know this is 30 degrees. This is the opposite side of the triangle from the 30 degrees. This is the hypotenuse. Opposite and hypotenuse mean you're going to go with sine. Sine of 30 equals X, opposite, over 5, hypotenuse. You cross multiply, the 5 comes up here. 5 meters times sine of 30 degrees is X. You can verify this on your calculator. X should be equal to 2.5. Ignore my bit of light reading for this trying time. So, by the way, I think we're all going to be fine. Just, it is a good idea to quarantine. So, now that we know the final height that this ends up at, oh, don't tell me my pen's dying. There we go. Now that we know the final height that this ends up at, we can talk about how work done affects this system. Since we know that the gravitational potential energy and Q, the internal energy change, because we're looking for how much internal energy was generated, we have this. The work done equals both the change in gravitational potential energy plus the internal energy. Okay? So what this boils down to is the work equals the difference in gravitational potential energy final minus gravitational potential energy initial plus Q. This obviously simplifies because initially there is no gravitational potential energy. So our work done equals mgHf for H final plus Q. Now we just plug in 100 joules of work were done. This is a 3 kilogram cart. The acceleration due to gravity is 9.81 meters per second squared. The final height is 2.5 meters. We are looking for how much internal energy was generated, how much energy was needed. Since 100 joules of work was done, how much of that went into overcoming friction? How much internal energy was generated? Okay, turn on my calculator. 3 times 9.85, or 9.81, excuse me, I don't know why I said that, times 2.5 is 73.575 plus Q. So Q is the remainder of this. So let's see, 100 minus 73.575. The internal energy was 26.425 joules. That is equal to Q. Now, there's a couple different things we could do with this, actually, which is kind of interesting. Since we know what Q is, and we know the mass, and we know the distance that it traveled, we could even go and figure out what the coefficient of friction was. That would be kind of interesting. We're not called to do that, okay? So, what we've done today is we've looked at how work and energy interact, how work changes the energy for a system or for an object. We've spent a lot of time looking at this. We've done a bunch of examples. This is, I think energy is, this part of energy is one of our trickiest units. Calculating energy is very simple, like calculating kinetic energy, potential energy. Those are easy. Calculating the work done is easy. It's when you start saying that work goes and changes the energy, there are so many different situations to look at. That is where this gets a little difficult. So my recommendation for this is always be thinking, okay, some work is done, how does the energy change? Which type of the 4 types does it change? Does it change kinetic energy? Does it change gravitational potential, elastic potential, or internal energy? Okay, how does the work done change? All right, these are trickier questions, and they are kind of the lead-in to our final topic for this unit, which is second to final, conservation of energy. At this point, if we were in regular class, what I would do is I would give you a quiz on work and energy where I'm asking you to calculate work, calculate the 4 types of energy, and then do a little bit of this stuff where you're saying, okay, how does work change the energy? Okay, this would be kind of the halfway point of our unit. Then, once we do that review and quiz, then we would go on to conservation of energy. Because I don't think I have a good way right now of giving you a quiz, I am actually going to hold off on all your quizzes in the hope that we can do them when you come back. We'll spend a few days reviewing each topic that we go over, then we'll quiz on it, okay? So, What we're going to do instead is tomorrow we're going to actually jump right into what I call conservation of energy. We're going to spend a few days on that. We're going to spend a few days on power, which is our truly last topic in this unit of energy. And then, like I said, because I would rather test when we get back to school, we are actually, after we finish power, take a few days to do that, we're going to jump into our next unit, which is electricity. My hope is that when we come back to school, we'll have some time, we'll go over these topics that we're kind of flying through, maybe do like a couple days of review on them, then take the test to get you back in thinking about them. So my recommendation to you is you need to make sure that you are paying attention to these notes, that you're following along, that you're doing the homework. So we're going to practice them now. We're going to move away. Then when we come back to them, they should be review, and we can see what we need to work on after your quiz or test. Again, if there are any questions, so there's no homework for tonight. Just make sure you have these notes written down. Make sure you're practicing these things and ask questions if you have them. If there's anything at all you need, even if it's not physics related, please let me know. If there's anything you need from school, hopefully you got the phone call this morning. You can go in tomorrow from 7 to 5 or Thursday from 7 to 5. I know the school is also, there is, I forget the details, but there's some sort of lunch or breakfast being served. You can go get that. Please, if there's anything that I can do not hesitate to reach out and ask. This is tough for everyone. We're going to make it through together. I hope you guys are doing well. Hope you've got enough stuff to read or do or watch. And, hopefully if everything works out well, physics can be a small part of that. But I totally understand that this is some weird times. So I really thank you guys for all your cooperation. Stay in contact, and I will see you tomorrow with another video. Bye.